Welcome to Lecture 10. In this lecture, we will continue the discussion on dynamic programming, and we have a new practice for you. We will talk about a problem called the longest common subsequence problem. So we will first see how we can find the length of the longest common subsequence of two input strings. And after that, we will introduce a technique called backtracking so that we can actually retrieve the longest common subsequence. And after introducing this problem, we will also make a mention of a related problem called the edit distance problem. So let's start. Okay, so first of all, let us consider a character string. Let's call it S. Now, if we remove some of the characters from S, but concatenate the remaining characters, then we will have a subsequence of S. So for instance, let's say S is abracadabra. So let's say this S is a long string like this. Suppose that we remove all these black characters and retain the purple one. After removing the black characters, but then concatenating the remaining purple characters in the order as they appear in the original string S, then we will form the string radar, radar. So radar is a subsequence of S by this definition. Now, we may also allow that we do not need to remove any characters. So in that case, the string S itself is also, so we just define this, is also a subsequence of S. Now, let us move on, and this time we consider two character strings S and T. Suppose that a certain string W is a subsequence of S, and also this W is a subsequence of T. Then in that case, W will be a common subsequence of them. Yeah, both of them is a common subsequence of them. So as an example, for instance, S, let's say, is dirty room, and then T is dormitory. Then in that case, we will see that DRY is a subsequence of S, and DRY is also a subsequence of T. So that means that DRY is a common subsequence of these two strings. Now, the longest common subsequence problem is defined as follows. So suppose that we have two strings S has length n, so S1 dot dot n, and T, where T has length n, 1 dot dot m. So we want to find a common subsequence of them such that the length is the longest. Now notice that the longest common subsequence that we have here may not be unique. So, but on the other hand, because it is longest, so that means that all the longest common subsequence, even though they are not unique, it means they must have the same length. Okay, so we want to find out what is the length of such a longest common subsequence and an example of such a longest common subsequence. And our strategy is to use dynamic programming to find the length. And after that, as mentioned, we will use the backtracking idea to output a certain longest common subsequence after that. Okay, again, this is a problem that we hope to solve it by DP. So let us try to think backward. So suppose that, okay, so before we move on to think, okay, so we will first define this term LLCS, the length of the longest common subsequence of two strings XY by this symbol LLCS. So LLCS of XY means it is the length of the longest common subsequence of strings X and Y. So that means that our target is to get LLCS of S and T. Now to think backward, let us look at a very simple case first. Now suppose that the two strings S and T, it just turned out that the last character of them are the same. Then do we know about the LLCS of S and T? Now if the last character of them are the same, then it seems that it is best to have the common subsequence ending with such a last character. Now if we can end with such a last character, then what does that mean? It means that what we need to do here is that we need to find out what is the best way to match the remaining part of S and the remaining part of T. So we remove the last character of S, remove the last character of T, and find out what is the best way, what is the longest common subsequence of them. After getting such a longest common subsequence, we will just add the last character so to make it longer. So although this looks natural, but this still need the proof. So to see why this is correct, so we will first see that if S and T ends with the same character, let's say this is the character C, we must have some longest common subsequence of S and T ending with C. Now, if it does not end with C, then what does that mean? It means that it ends somewhere before S of N, right? Because it is not ending at C. And also it ends at somewhere before T of M. But then, this cannot be a longest common subsequence because we can always include one last character, the character C, to make it longer. So we have the claim. So it must end at the character C. Now, once it is known, then in that case, we can always convert any LCS of S and T in a way such that we are always using the subsequence ending using S and N, S of N, and T of M. So I will leave this for you to formally figure out why this is true. But then the intuition actually tells us that once the last two character matches, then we can solve the original problem by solving the subproblem. So in particular, LLCS of ST is just 1 plus the LLCS of S taking away the last character and T taking away the last character. Now this is one case, but this may not be all the possible cases, right? So that could be the case that Sn and Tm are different. But if such a case happen, then we know that the longest common subsequence cannot end with Sn or it cannot end with Tm. Because these two are not the same, right? So either it is not ending with Sn or it is not ending with Tm. So it cannot be end at Sn and Tm, right? Because they are not the same. Now, if it does not end with Sn, that means that the character of Sn is unrelated. So in that case, the LLCS of St will simply be the LLCS of S removing the last character with T. And similarly, if it does not end with T of M, then that means that the last character of T is useless. So in such a case, LLCS of St will be equal to LLCS of S with T, but the last character is removed. However, we do not know which case really happens because we do not know any information about this LLCS or LCS. But we do not need to worry because LLCS of St is always the maximum of these two cases, right? We can just compare whichever gives us a longer LCS. Then the longer in length will be the length of the longest common subsequence of S and T. So we just get this one and get this one and compare whichever is larger. Now in general, so this is not just happening for the last character of S and the last character of T. So in general, suppose that we have S for the first I characters and T for the first J characters. We want to compute the LLCS of S and T in these two cases, S1.I and T1.J. Now, we will, how do we compute it? So we can base on the similar argument as before. If the last character of this Si and Tj are the same, then it can be computed based on this value. We get this value, plus 1. This will be the result. On the other hand, if the last character Si and Tj are different, then it is based on whichever value here and here is larger. It is the maximum of this value and this value. So in that case, this is what we need. Okay. So the idea here is that whenever we want to extend, okay, or compute S1.I up to T.J, then it just depends on removing the last two characters of them respectively, or removing one character from S or one character from T. It seems to be easier if we provide an example for you. So let's see how we can compute the longest common subsequence of dirty room and dormitory. We focus on the length. So here, the 0 here represents that when you have nothing here, then the longest common subsequence of this term, this entry means that nothing compared with D. This one is nothing compared with the string Di, okay? And so on and so forth. So we try to fill in this table one by one. And then, so what does that mean for this one? So let's see this example. Now this entry represents, we are looking at this character D and this character D. And then we want to find out what is the length of the longest common subsequence of them, D and D. Now, because these two characters are the same, then it must be 1. Or we can easily see that it is the case of 0 plus 1, because it is 1 plus whatever that is the best if this character and this character is removed. So this is 0. Now, how about this entry? This entry represents, we want to find out what is the length of the longest common subsequence of D versus DO. When D is versus DO, we find out that the last character are not the same. One is D, the other is O. So either it is due to the removal of this character or the removal of this character. Am I correct? If we remove this character, then we are finding the best way to match this one with this one, so which is this entry. If we remove this character, we are finding the best way to match this one with DO, which is this entry. So this one really comes from the maximum of this entry and this entry. So 0 and 1, we get a 1. Similarly, R and D are not the same, so we compare 0 and 1, we get the larger. M and D are not the same, we compare 0 and 1, we get the larger. And so on and so forth. So in the end, we fill up the first row. Now, how about the second one? The second one, let's also do this again. When we try to fill in this entry, we find that D and I are not the same. So we are comparing the maximum of these two, so we get a 1. O and I not the same, maximum of these two, we get a 1. Up to this point where we have something that we want to see. When we have I and I here, the last characters of these two strings are the same, so we are comparing DI with dormi. The last characters are the same, so the best way will be 1 plus this corner. we delete this character and we delete this character and find out what is the best way to match the remaining. So 1 plus 1 is equal to 2. And then for all the others, it is not the same as I, so it is the maximum of these two, we get a 2, the maximum of these two, we get a 2, the maximum of these two, we get a 2, and so on and so forth. When we fill the third row, so we will have the maximum of these two get 1, maximum of these two get 1, and then at this point, it's not the maximum of these two. It is because it is R with R. So we are adding 1 to this entry, so we get a 2. Maximum of these two get 2, maximum of these two get 2, maximum of these two get 2, and so on and so forth, up to this entry. For this entry, we compare this R, and they are the same. So it is 2 plus 1, we get a 3. So we can fill in the table again and again. So row by row, so in the end, we have computed everything. So we will obtain the so-called the length of the LCS of the original input 2 strings. So we find out that there will be a longest common subsequence of length 4. But it may not be unique, but at least the longest common subsequence for these two input strings will have length 4. Now, the previous run allows us to see how we can compute LLCS of ST. We basically compute LLCS of S1.i, T1.j for all the possible values of ij. So that means that we have computed all the entries in this table. Now, when we compute a certain entry, we just make constant amount of time. Yeah, because we either compare these two or we add 1 to this value. So all the previous terms, so when we compute this entry, we just take a look of this entry or this entry or this entry, all of them in constant time, so that we can be able to deduce what is the correct value to be filled in here. So each entry takes constant time, and there are altogether nm entries to be filled. So altogether the time is nm. But this only gives us the length of the longest common subsequence. So how can we obtain the actual longest common subsequence? How do we get this?